honestly, just a minute. What's the math equivalent? What should we do before 5? If you would change policies right now and inform whoever your governor will be what they need to do. Oh, no laughing. I stay very politically. Call out real quickly. What did you hear about? We talked about doing the numerals right up front. Teach the numerals. Teach the movement of the numerals. Right? I don't know if you know all the numerals. One, but right. 3 is around and back on a railroad track. 4 is down and over and down some more. That's the way we make a 4. Right? I don't know if we can say this in public school, but across the sky, down from heaven, that's the way we make a 7. Right? All the different things you can do to create that numeral approach. Those are our starts. Anybody else add to that?
Take add textual. This is old textual, some old. But you do good jello, just in a dry bowl. Got your 7. That's good.
It's great. See, we're so used to doing shaving cream in our class. Sugar goes a long way. We did Kool-Aid in my house. That's awesome. We did that. All right, you also had counting.
Yeah, we were just talking about Cheerios and stuff, just when they're starting to, be counted for. They're 5, and they may not be able to verbalize them, and they.
And so we have then count. Think about the new toothbrushes that have like a vibration piece that starts at like after 30 seconds or whatever. I hope it's long enough for my kids got love them. The teenagers need to brush more. Further out there. By next Monday, I took the brushing like 5 minutes. Okay, we got lots going on. I mean, we attach a toothbrush to their mouth as they walk around. But instead, you have them count it out rather than letting the timer do it for them.
We were talking about vocabulary, like, knowing what they are, because, even, I was just saying, when I used to do discrete child training with severe autism, and one of the things that I did with one of my kids, we had one of the classic, like, bowling sets. You got the bowl, but not only did you have to count how many you knocked down, you had to count how many you had left. So, we were doing it twofold, but you've learned that vocabulary too.
I'm going to steal that idea. Right now, I'm working with PE. In South Carolina, I don't remember North Carolina's laws, but we have certain laws of physical activity that must be done, the obesity laws. They're called the obesity laws, but nobody wants to say that. But making groups of 10 is a very, very important skill to build on. So in other words, when you're getting the negatives, like last week, when you go, if some people out there, I don't like that, I'm right there with you. When we have trouble, we find that the kid can't subtract because they don't understand groups of 10. 6 plus 4 equals 10. 10 minus 4 equals 6. 10 minus 6 equals 4. That triangular effect. That bowling of 10 pins could do so much for them. How many were knocked down, how many are up, how many were all together. Okay, any more? Throw them out at me. I need to steal that one. Yeah.
Sports is huge. My son taught himself by 2 to 7. It's just by watching sports.
You got it. In football, so now I read research that 7s and 6s are some of the hardest things for kids to memorize in multiplication. I'm like, really? How did that? That was the first I learned. I mean, come on. All right. The idea is we have things we can start early with them. We are not going to change politics today. Please know I'm glad the election's coming up. Teachers, I don't know if North Carolina's voting, but I can tell you in South Carolina, there are less than 40% of the teachers are even eligible or registered to vote. When I say eligible, they're not registered to vote. Less than 40%. And then teachers are always upset about whatever is going on in politics. And I got to say, well, stop. Go register and vote. So I hope that you guys are on the same piece where that's getting about with their kids. So, all right, stop talking, here we go. Tell me what's happening mathematically here. This is how your standards are developed. This is how standards are developed now. By the way, the numbers did not change pre-Common Core to post-Common Core. 4th grade, 18% of the students are scoring below basic. Y'all know those number things? Okay, right? There's advanced, there's proficient, which means you met grade level expectations. Proficient is no more exciting than that. Proficient is not awesome. I'm sorry, I love my kids and they come up, I'm proficient. Yay. Yeah. Then there's basic. Basic means you really did not complete the grade level expectations. Yes, you understand most of the material, but you've got some holes to fill. And then there's below basic. You're in trouble. You need intense intervention. So take a look. This is Gen A. In 4th grade, 18% of our students in the United States are already, almost a fifth, are already below basic. And then, over a quarter are below basic by the time they hit 8th grade. Think about this, it is increasing in number. The 12th grade test is completely changed, so we don't do it, but the former 12th grade test was 36% below basic, and the numbers were very similar. Take a look at what happens for students in EC. By 4th grade, we already have near half of us are below basic, and then almost 2/3 of us are below basic by 8th grade. Why the increase? Why are these kids' problems going away? It's the same problem. In math, it's called a study of compressibility, which means that if there's a problem here, in whatever approach, I don't want to keep saying what I said because I'm going to have you map it out. Whatever this problem is, it probably existed somewhere else in a different form, and it's going to affect them later on too. Once it starts as a problem, it is hard to get rid of a problem in math. Math is not literacy. There is no capping, right? Oh, he's reading at the 5.5 grade level, we like to say. Look, he's literate. There is no matherate age. There is no cap. Math is a take it till you fail it subject, and then you take it some more. Math has no ceiling. Everybody in here stopped math too early. Theoretically, all of us should have kept going to math. If someone has got a PhD in math, no one gets really excited by it because it just keeps going and going and going. I remember my dissertation defense. I remember Dave Miller asking me stats questions, and he just kept harder and harder. And at the end, I go, Dave, I just don't know the answer anymore. And so at the end of the defense, Dave fell asleep, by the way, halfway through. And by the end of it, I remember leaving, and Cecil Mercer pulls me aside and he goes, all right, Brad. I go, oh shoot, I really bombed with Dave. He goes, are you kidding? We didn't know what he was talking about. Because he kept asking you harder and harder and harder questions until he figured out your ceiling. Once he understood your ceiling, that's when he tuned out. Okay, he's well beyond my needs. And then everybody else asked other questions that I could answer every one. Because in literacy, you can always go another route to answer a question. But in math, there's a ceiling effect that is really a glass ceiling. Every kid thinks they've topped out at some age, but they haven't. It takes something else to get them past. So, it's our turn. All right, first, algebra is like X-rated arithmetic, right? No, nobody, oh gosh. I killed the joke, did I kill it? It was better there. Sorry, hush my. No, okay, I just did horrible things. All right, see, easy, thank you. One person goes, I get it. Yeah, you didn't laugh, thanks. All right, so Council for Exceptional Children recognizes this as a problem, and no longer are we going to be trying to get kids to algebra. Now, I think algebra 2 would be math 3. Okay, so now here, we need kids to get to math 3. Real quick, let me do the explanation. Algebra is no longer what algebra once was. There was a time when everybody in this room, algebra was a little textbook. And then they said, oh shoot, kids aren't doing great in algebra, so they said, let's make it algebra 1 and then algebra 2 trig. We're going to combine them. Then they said, that's not enough. Let's make it algebra 1, then algebra 2, and we'll put trigonometry. We'll call that, let's call it pre-calc. That sounds really exciting. Right. Then we said, we're still not doing well, so we're going to go talk to kindergarten kids, and we're going to say the word algebra to them a lot. And if we keep saying algebra, they'll be really comfortable by the time they make it to algebra. And then they can take algebra 2. So far, what are the scores doing this whole conversation? You got flat line or the general demise continues. So now we are somewhere along the way of, we say the words algebra, then middle school is all pre-algebra, and then they take algebra, And then they get to an Algebra 2 understanding later on. You guys have had a cool combination, which I think is unique, and I like it. But let me describe some of the data of what happens to kids with LD during pre-algebra. It is a standards issue. So when we went through, we did the algebra readiness test. How well should you do when you're in algebra on the algebra readiness test? You hope really well.
Proficient.
Proficient, barely. But here's what we're finding. We found no statistical growth in data and probability in 6th grade. But we did have statistical growth in algebraic development in 7th. No growth in equations, no growth in equations. No growth in decimals, no growth in decimals. Not significant growth in exponents, not significant growth in exponents. No growth in fractions, no significant growth in fractions. Computation, minimal, not significant growth, no growth. Graphing, no growth, no growth. I don't know what an integer, okay, there we go. And then we have no growth, no growth. In other words, on the algebra readiness test, these students who passed with A's and B's and LD actually had no statistical growth towards algebra. So they were doing well in 6th grade, they're doing well in 7th grade, and then they are going to be moved into Algebra 1 in the 8th grade. And the predictability of it, they will fail miserably. Because it's not the teacher's issue. And I'm going to blame it, not the kid's issue either. The standards don't align to algebraic understanding. So guess what? We've got to have a change. So I mentioned Algebra 2. Do you all know this research? Can I just move quickly through? I'm trying to excite you. This is the adrenaline shot right now. If you think that your kids they made it through algebra, understanding Math 1 and were successful, that is not the research. Because of what we've done to algebra, killing algebra, Algebra 1 no longer predicts anything. Algebra 2 now is the predictor. So in California, they have a huge dropout in community college. So they did statewide, why are kids dropping out of community college and technical school? 70% causation, lack of Algebra 2 understanding. Even if they passed Algebra 2 understanding, they pass it course-wise because they did all their homework. They still don't understand Algebra 2, which means what? They don't get a technical degree. Because what happens at the community college level, they give them a placement exam. No matter what classes they do, no matter what scores they get on the SAT, they give a placement exam, and the kids are put back into basic baby Algebra 1 math. And then they're not graduating. 70% of the dropout in community colleges are due to it. In fact, they're predicting that 70% of all, they can predict who is going to make it through college and who won't make it through technical school. And by the way, those guys make more than us, right? The repairmen of the world, the plumbing. And these are the people you want to do very well their job. The DA in Work County, who's a buddy of ours, his car actually just blew up over the weekend. Because, if you know, I don't want to steer the car, it's a hybrid, and the battery technology, it went all Samsung Galaxy on him in his driveway. And it burst into flames down to bare bones. And of course, they saved most of the house. What I'm getting at is, though, if the mechanic is not good, and they decided, like 90 times out of 100, they parked in the garage, and that night, for some reason, decided I was too tired coming in late. So he left it in the driveway. Thank goodness. What I'm getting at, though, is this is an important piece. We need these people to do awesome at their future job. And they're not making it through any of the training. So it's our turn. It says, yeah, I don't have trouble remembering my timetables, but I stink at algebra. What are the skills that lead up to algebra understanding? So I'm going to go here. I've done all my good stuff. Wait. I want to there it is. Grab yourself a note card here. I gotta get you toys. Grab yourself a sticky note, one per person. If you teach multiple grade levels, I'm ready for you. I have extra stickies. Tell me your name. Willie. I'm going to put the extra stickies in front of Willie. So if you have multiple grade levels, see Willie. Now, what I want you to do is write down what is it about that grade level, and then please change the math step. If you were to jump into, like, if I'm a 3rd grade teacher, I think students should be able to blank, blank, and blank, but they don't. So it's what do students walk into your grade level with and lacks that skill. That you don't think you should be teaching it, but you have to teach it every time. All right? When you're ready, take a look around. Kindergarten, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, Math 1, Math 2, Math 3. And put the sticky note underneath there. All right? All right. Give you 5 minutes.
One thing?
Multiple things. That way you can put it underneath those colors.
Oh, you're okay. Excuse me.
I won't show my slide around in a couple seconds.
I think everybody talking about it was, yeah. I mean, trying to pick that up, but our health coach, she would be the one that, would get the food, so.
There's not really anything out there that I did this year for them to go see. Because I've already looked into it, there ain't nothing out there that I know of. But I mean, we can even do something else. Bowling and restaurant.
Bowling is not look, map or will. But, look, you don't have to make one.
A reminder, while you've got a minute, if you've not signed in, back here, please do.
But you need a break now.
That's tomorrow. I'm not working. Shouldn't leave these out.
Conspiracy stuff. About like Kennedy, shot by
It should be, yes. I just gotta make sure the light
All right, let me go through real quick what we've got here. Let's see if there's a pattern building. And I did not peek at all. So as I read through this, I want to see, are you going to find a pattern built? I'm going to start, by the way, I used to start at the upper level and move down. It's easier to start here and move up. And I hope that we recognize a couple of patterns here. Socially, there's a pattern, and mathematically, there's a pattern. Here we go. Number sense, recognition of number counting or recognition numeral. Subitization, like small groups at a time. Counting to 10, basic shapes, basic number sets. K and 1, flexible with number understanding. How to identify, write, and make a number. Subitization, automaticity with addition, subtraction. Place value. Counting one more. If you haven't heard that as strategic counting, the one more principle is one of the very, very early strategic counting principles. First grade, number sense, partitioning, one-to-one correspondence, place value. Also first grade, place value. So far, they don't know their numbers and they don't know place value. I'm going to make sure you understand this. I hope we're all together on this, right? Place value is number recognition. 12 is not a 1 and a 2. That's where the computation errors become more prevalent. That's when a teacher doesn't have number sense and is teaching. You hear that in the computation frequently. None of us, of course, you were crazy enough to choose math. So I'm expecting this to be different. All right, second grade time. Single digit addition, subtraction, place value, subitization, memorization of addition and subtraction, place value, number sense, time, adding, and subtracting. Why time? What is it about time that connects to all of this? It is a number sense, skip counting. Math begins as a one-dimensional piece, forward and backwards, which is why last week, I on purpose, I started describing not a number array, but a number line. So I started saying, can you go both ways on this number line? Or do we wait till they turn 11 before you introduce them to a number line? Right? Because before that, it's a number array. You go, I've been lying for years, it goes that way too, right? Are we really starting with this? And time is one of the factors of going negative. because that's when you say 30 minutes ago. Oh, you missed it, we can't do that anymore. Where, I don't know if kids hear that as often as they probably should, but that's another thing. Number 3 here, there's 3rd grade. Place value, counting using base 10. Subtraction, one-to-one correspondence, place value, addition, subtraction with regrouping. Kindergarten, 1st, 2nd, 3rd, we've heard now the same thing repeated. I bet the problems all go away in 4th grade though, right? Place value, multiplication is now interlinked. Listen, they weren't adding and subtracting and didn't understand place value, size of the numbers, and they couldn't figure out linear approaches. What's going to happen in multiplication? Well, it's going to be a problem. Multiple digit addition, subtraction, greater than, less than, like magnitude comparison. Basic times tables, again, single digit addition, subtraction, multiply, divide, multiplication. Need to know fractions, with a level of understanding. Place value, addition, subtraction, regrouping. Place value, yay, word problems, finally, we're going now vocabulary. Listen, it was a problem earlier, but they didn't understand the place value. That was the language system coming in. And now the language system's getting bigger, which is why we were saying earlier, math needs to be treated like a language early. Of course, I love it. All right, so let's keep going to this one. Multiplication facts, fractions, place value, subtraction, number sets, place value, all computation, problem solving, multiplication facts and steps, 5th grade, decimals. Students need to be able to multiply and divide and understand the similarities of the skills. Multiplication, multiple digit addition, subtraction, 1 and 2 step problems, add, subtract, multiply, divide, multiplying 2 digits by 1 digit, skip counting, which is understanding multiples. Right? Skip counting is supposed to be, if I started at 3 and I skip count by 5, it goes 3, 8, 13, 18, 23, 28. That's skip counting. But many of us we've given up on that skip counting. We just want them to know the multiples. 5, 10, 15, 20, right? So we've got skip, and then knowing how to multiply and divide with understanding. We get to 6th grade, do you think we're going to hear the same thing? Yeah. If you ever do this as a group, if you were able to get a school together to do this, they come in, you have them meet by grade level teams, and you don't let them report out like this, this is when you start hearing ditto yelling out of people's mouths. Right? You take, let's go 6th grade, ditto. In other words, problems aren't going away without a strategic, sincere approach to making it go away. 6th grade, multiplication, division, fractions, long division, multiplication facts, place value, multiplication, decimals, fraction. Multiplication facts, addition, subtraction, multiply, divide, and place value. 7th grade, understanding distributive property. Uh-oh. I thought it was a spoiler. You have to really know the full property? I didn't know that. Please, okay. Kidding. Understanding your properties, converting improper fractions to mixed, and vice versa. So computation is starting to build the concepts. All right, what are we going to hear in 8th grade? The same thing. If we had a larger 8th grade group here, it would be just the same things. And when I look, multiply, decimals, percents, fraction, right? And then place value. And percent, we write percents in a certain level because it looks like a decimal. Please know in the research, they're not called percents and they're not called decimals. And they're not called fractions. They're actually put together and they're called decimal fractions. They should all be taught similarly. And I hope we touch that much better next time, but if we get a chance, I'd love to show you some interventions today. All right, math 1. Multiplication, division, multiplication, fractions, order of operations, negative numbers, fraction operations, graphing begins. Yay, now we got graphing. Linear equations, integers, fractions, simple equations, multiplication. Hold on, get my breath back. Regrouping, multiplication, any basic fact, multiplication, abstract math, addition, subtraction, multiplication, division. Oh my gosh, this person has a whole litany here. Rounding, fractions, reasoning, slope, intercept, law of exponents, and solving for equations. Basic math facts, fluency, word problems. Are we catching up? Yeah. I want to give everybody good credit for writing it, but it's going to say the same things added on. Surface area show up, vocabulary kicks back in, factoring kicks back in. Well, of course factoring kicks back in. They couldn't do it with whole numbers. What are you going to do when you throw an X in there? It's going to be, oh, that's totally different. Well, it's totally different because of how it was taught earlier. It shouldn't be different. So, as we go through and these things repeat themselves over and over again, even math 4, fractions, factoring, word problems. So what you guys have come up with already is once a problem, always a problem. Problems don't go away in math. This is not a, oh, listen, it's history, which I love history, but if you didn't like this generation or this study, you're going to move to another one next time. The teacher may make connections, but you can still survive. That doesn't happen. That's why RTI and math have been a real hard combination in research, because it isn't the same thing. There aren't splintered skills to clean up while you're learning. It's splintered skills to clean up, and you're struggling with it. Nothing goes away. So here's what we're going to do. Which one of these, this is your job, which one of these is an intervention that you should focus on, and which one of these is a core problem? A core problem means we need to change this. This isn't just EC. This is Gen Ed, repeated problems. We need to have this cleaned up at the Gen Ed. We don't need to spend 3 weeks in 4th grade on this anymore. It looks like we can spend about 4 weeks in 2nd grade, a couple weeks in 3rd grade, and finally in 4th grade a month on this. Which one of these is core and which one of these is sparsely put in there? We could do interventions and clean that up. All right? I'm going to have you solve the world in about 3 minutes. All right? Go get it.
You don't understand the questions that are trying to come and reason that you have a college or not, you don't
About a minute,